Hey everybody, in this section we're going to talk about solving exponential and logarithmic equations. We saw a couple examples of this in the previous sections in 5.1 and 5.2, but this section is really focused on different methods of solving and different types of equations that involve exponentials and logs. Okay, so the first example we're going to do is a lot like what we saw in 5.1. Okay, so the trick with these exponential equations is to try to isolate the exponential if you can. Okay, so I'm going to divide both sides of this by 3. Oops, yeah, x plus 3. Okay, and then we're going to check if it's possible to use equating exponents. Okay, so remember what you need is to be able to write everything in the power of a single base. So you can see everything here is really related to 2. So we are going to be able to use the equating exponents, and we're going to write everything as a power of 2. Okay, now we're going to use our exponent rules to simplify this side. Okay, and now we are actually able to just equate the exponents. Okay, and the last thing I need to do is just subtract 3 from both sides. Okay, so there's my solution. Okay, so that's just a little reminder of how to use the equating exponents method. Okay. Okay, so here we're still going to try to isolate the exponential part first, so we're going to subtract 7 from both sides. Then we're going to divide both sides by -2. Okay, and I wanted to do this example because this is actually a situation in which you can just say what the exponent is. Okay, so there's 2 ways to think about why this is the right exponent. Okay, so remember anything to the 0 power is 1. So specifically in this case, e to the 0 power is 1. Okay, so that would allow us to equate our exponents and get our solution x equals 0. The other way to think about this is to take the natural log of both sides. Okay, so the natural log of e to the x is x, the natural log of 1 is 0. Okay, so either way you're thinking about solving this, you are still going to get the solution x equals 0. Okay, all right, so let's look at some slightly more complicated examples of this. Okay, so same methods, just a little bit more complicated. Okay, so here we're going to solve and we're going to give an exact solution, and then we're going to use our calculator to get an approximate solution. Okay, so let's look at our first one here. Okay, so the first thing we're going to do is divide both sides by 2. Okay, now you can see that we can't use equating exponents because this side is a power of 3 and this side is a power of 2. Okay, so in that case we need to take the log of both sides. Okay, now over here this simplifies to x plus 1. Okay, and this is just a numerical value that you can't evaluate by hand, so we're going to leave it like this. Okay, And at this point, all I need to do to isolate x is subtract 1. Okay, so this is my exact answer. Okay, and even though we don't know what log base 3 of 2 is, this is just a number value, so this is definitely a good answer. Okay, now if we wanted to get a calculator answer, we would need to use the change of base formula here. Okay, and this would allow you to plug it into your calculator and get approximately negative 0.37. So this would be our approximate answer. Okay. You don't need to do this to give your exact answer. The only reason we're doing that is to be able to plug it into our calculator. Okay. All right. Let's look at another one of those. Okay. So the first thing we're going to do here is subtract 1. Okay, and then we're going to divide by 3. Okay. And then we're going to check that we can't use equating exponents, which you can't because this can't be written as the same base as this. Okay, so we're going to take log base 5 of both sides. Okay, now over here this is going to simplify to 3x plus 2. Over here I'm not going to simplify it, I'm just going to leave it like this. Okay, and now I'm going to isolate x. Okay, so I wanted to remind you that there's no algebraic way to combine this stuff, so you should just leave it like this, and this is my exact answer. Okay, now to get my approximate answer, again, I'm going to have to use my change of base formula here. Okay, so just for variety, we'll use natural log. Okay, so we'll end up with this, and when you plug this into the calculator, you should get approximately negative 0.61. Okay, all right. Let's see a different kind of example, okay? Because those are really similar types of examples, they're just harder to the ones that we saw last time. So let's see a different type of example. Okay, so in this example, we're only going to give an exact answer. Okay, now this should look familiar to you guys because this is actually an equation that's quadratic in form. Okay, so if you can't see that, remember you can always do the u substitution thing and let u equal e to the x. Okay, so this would give you u squared plus 2u minus 15 equals 0. Okay, then you can see that you can factor this. Okay, and that will give you two things, u equals negative 5 and u equals 3. Okay, so remember, if you don't need the u substitution, you don't have to use it. It's just a tool for you guys. Okay, so we're going to go back to e to the x. That is something you have to do. Okay. All right, so let's look at this for a second. Okay, now e is something like 2.7, and this is going to be an exponent of e. Now, if you think about this, if you're taking a positive number and raising it to an exponent, can you get a negative number? Well, no, you can't. Okay, so this actually doesn't lead to any solutions. Okay, so there's no solutions to this equation coming from this factor. Okay, over here, we can take the natural log of both sides. Okay, and that gives us x equals natural log 3. Okay, so that's really our only solution to this equation, right? This doesn't lead to any actual solutions. You would get, if you use the same method without thinking, you would get natural log of -5, and you know that natural log isn't defined for any negative numbers. All right, let's look at another one like that. Okay, so here I'm going to show you what it would look like if you didn't use the u substitution and you just factored directly. Okay, so we're looking for something that multiplies to -4 and adds to 3, so it should be +4 and -1. Okay, instead of each of our factors equal to 0. Okay, we get e to the x equals -4 and e to the x equals 1. Okay, so again here this doesn't lead to any solutions because e to the x is never going to be negative. Okay, here e to the x is 1 when x is 0. Okay, so here we actually talked about in the previous example why that's true. So this is really our only solution here. Okay. So let's look at some examples of other types of equations that include exponentials. Example number 4. Okay, so here okay, so this style of equation where you have the fraction and an exponential function is actually really common in biological modeling. So I want to make sure that you guys who are interested in biology and science has seen some examples like this. Okay, so the first thing we're going to do is just use our normal technique and do some cross multiplication. Okay, so we're going to multiply that out. Okay, and now we're going to isolate the exponential. So we're going to subtract 2 from both sides, and then we're going to divide both sides by 2. Okay, and now to get rid of the e to the x, we're going to take the natural log of both sides. Okay, this is just a number, and this simplifies to x. Okay, so this would be our final exact solution. Okay, so this just kind of combines a solving technique that you guys already know, the cross multiplication technique, with how you solve exponential functions by taking the log. All right, let's look at one more like that. Okay, so again, we're going to use cross multiplication. Okay, so this time instead of multiplying this out, I'm actually going to start by dividing both sides by 6, just showing you guys some options. Okay, I'm going to simplify. Okay, now I'm going to subtract 2 from both sides. Okay, and I'm going to divide both sides by -1. Okay, Now to get rid of the e to the x, I'm going to take the natural log. Okay, this doesn't simplify. Oops. And this side does simplify just to x. Okay, so that would be my final exact answer. Okay. If you wanted an approximate answer, because this is the natural log, you could really just plug it right into your calculator already in this form. Okay, all right. So let's talk a little bit about log equations now. We saw only one super basic type in section 5.2. Okay. And so I want to talk about some other types. But first, let's just review that a little bit. Oh, this is actually a different type than what we saw in 5.2. Okay. So here, okay, if we didn't already have the log isolated, we would want to do that first, okay? But in this example, we do already have the log isolated, okay? So what we're going to do now is change to exponential form, okay? So the base of the log becomes the base of the exponent. This becomes the exponent, and the inside is 3x minus 1, okay? So you guys should have seen this technique before, okay? But I'm just reminding you of how it works. Okay, so now to isolate x, we're going to add 1, okay, and then we're going to divide by 3. Okay, so this is our exact answer, okay? If we wanted an approximate answer, you could just plug this into a calculator and you would get something like 2.80. Okay? All right. Let's look at one more like that. Okay. So the first thing we're going to do is isolate the log. So we're going to subtract 1 from both sides. Okay, and then we're going to divide both sides by 2. Okay. Once you have the log isolated, you want to change to exponential form. So the base of the log becomes the base of the exponent. This is the exponent. Okay, and then this is my answer. Okay, and then all I'm going to do is subtract 5. Okay, so as you guys can imagine, this is actually a giant number because 10 to the 13th power, right, is 1 with 13 zeros. Okay, so even if you take the square root of that, you're going to get something super large. Okay, so this ends up being something like 3 million. Okay, all right. So these are what I would consider like basic examples of solving log equations. So let's do something a little bit more complicated. Okay, now this has 2 log terms, right? So what would you do to isolate them? Well, we're going to use the log properties to combine these two. Okay, so this is one of the main applications of simplifying using log properties, is you would actually be able to solve an equation that has 2 different logs in it. Okay, so now we're going to do the same thing. We have the log isolated. We're going to change to exponential form. So the base from the log becomes the base of the exponent. Here's my exponent, and this is 3x over x plus 1. Okay, and now this is just a rational equation. So I'm going to multiply both sides by x plus 1. Okay, multiply this out. Okay, so I'm going to gather all my x terms on the left here. and move everything else to the right. Okay, and I'm going to factor out my x. Okay, so this would be my exact answer. Okay, if you wanted an approximate answer, you could certainly plug this into a calculator, and I promise you it would just give you a numerical value. Okay, all right. So let's see one more that's like this, where we have to use the log properties. Oops, shaky cam. Okay, so here we're going to use the log properties to combine these, and this is going to be multiplication this time. Okay, and I'm actually going to multiply this out. Okay, so here I'm going to change to log form, so the base of my log becomes the base of my exponent. Here's my exponent, and my answer is x squared minus 2x. Okay, so this is going to be 8. And because I have a quadratic equation, I'm going to move everything to one side and try to factor. Okay, now this does factor. Okay, and this gives me two solutions, 4 and -2. Okay, now we talked about this yesterday, okay, and we're going to talk about it again. When you're solving log equations, you do have to check for extraneous solutions, okay? We didn't actually check for them in the previous examples because it would have been difficult to plug those numbers in, but I assure you those are not extraneous solutions. Everything is a-okay there, okay? When you look at these and you look at this original equation, right, we want to make sure that whatever this is, the argument of this function is going to be positive, okay? So if we plug in 4, we'll get 4, that's positive, that's fine. 4 minus 2, that's 2, positive, that's okay. So this one is going to be a good solution, okay? Now with -2, we would have -2 here. Okay, that's going to be an extraneous solution. Okay, so like I mentioned in one of the previous examples, if you have two candidate solutions and one of them is extraneous, that just makes the other one your actual solution. Okay? All right. So let's do one last type of example. Okay, and this is a little bit different because the variable is actually in the base. Okay, we're going to use the same technique. You're going to isolate the log. Here it's already isolated. Then we're going to change to exponential form. So b squared equals 9. Okay, and this would give us b is plus or minus 3. Okay, now it's important to remember in these examples what b is allowed to be. So b, the base of the log, actually has to be a positive number. Okay, and it also can't be 0. So this, we're going to have, I guess I'll write it like this. Okay, this one is extraneous. Okay, and our actual solution is b equals 3. Okay, let's see one more like that. Okay, so the first thing we're going to do is isolate our log. So we're going to subtract 1 from both sides. And then we're going to divide by 5. Okay. Now that we have our log isolated, we're going to change to exponential form. So we have b to the 2/5 power equals 4. Okay, and now this is a power equation, right, where you want to get rid of the exponent. So we're going to rewrite this as the fifth root of b squared. Okay, so to get rid of the square, I'm going to square root both sides. Okay. All right, so here I'm going to get the fifth root of b. Here I'm going to get plus or minus 2. Okay. So to get rid of the fifth root, I'm going to fifth power both sides. Okay, so this is going to give me b, and this is going to give me 2 and negative 2. Okay, so again, the base b can't be negative, so this is extraneous. Okay, and my actual solution is b equals 2. Okay. All right. So I hope that you guys have seen kind of the more base examples of this and you're understanding the more complicated examples. If you need any help, let me know, and I will see you guys soon.